Okay, so today we're going to talk about something called stoichiometry, and that's what this is down here. So you do need to draw this little shape. It will probably take up most of a piece of paper. This is almost an entire piece of paper. But we are going to be converting from different substances now. So previously in the boxes, when we did the box method, you only ever had one compound over and over, but now I'm gonna show you how to switch, okay? So it's very, very important that you are writing the compound in each of the boxes, okay? So in order to draw this big giant shape, okay, you're gonna start over here with grams of A, and that's gonna come from the periodic table. Then this is 1 mole of A, the same substance, okay? And then down here is molecules or formula units of A, the same substance, and that number we've already talked about is 6.02 times 10 to the 23rd. Okay, the B side is exactly the same, just replacing all the A's with B's. Okay, same numbers, same everything. And then you have this thing in the middle connecting them called the mole ratio. Okay. All right, so take some time to pause the video and draw this. Okay, you may need to do it in parts, but you do need to draw that because I'm going to be using it. Okay, so we're going to do some examples. We're going to start off really simple with one-step things, and then I'm going to show you how to do it with just a little bit more than another step. We're going to also do this tomorrow and the rest of the week, okay? So this is mole to mole. All right, so the first question says, how many moles of water are produced if 15.0 moles of oxygen are produced in the reaction? So you cannot do stoichiometry without a balanced reaction. If you don't have a balanced reaction, you don't know the mole ratio. These numbers in front, these coefficients, are going to become part of our mole ratio, okay? So you're gonna have to follow me, and this is gonna be weird, okay? But I think it'll be all right. So it says how many moles of water, okay, so that's H2O, are produced if 15.0 moles of oxygen. Okay, so we're going to start with that. That's going to be the same. 15.0 moles. That's the same. And then we're going to write oxygen. Oxygen is written as O2. So none of that is different. That is all the same. You're still never going to have anything in this box. Okay. So just like before, if this is moles of O2, then down here has to match so we can cancel it, is going to be moles of O2. I'm going to adjust the camera a little bit. Sorry if it moved. It was just a little unlevel. Okay, so 15.0 moles of O2, and we're putting moles of O2 down here so it can cancel. Okay, and then the question says, how many moles of water? Okay, so what you're going to do now is we're going to look at our little map, and we're going to figure out where we're starting and where we're trying to go. Okay, so we started with moles of substance A. That's where I'm at right now, moles of O2. Okay, and it's asking for moles of water. Well, that is a new substance. We're starting with moles of O2, and I'm asking about moles of water. That is something new. So that means we are converting something. We are changing something. Okay, so I have moles of A here, and I'm trying to end up in moles of water, which is going to be my moles of B. Okay, so I'm starting with moles of one thing and ending with moles of another. So that can be done in one step because the mole ratio connects them. Okay, we're going to do some in just a minute where we start maybe down here, which we cannot do in one step. Okay, so for now, moles to moles can be done in one step. The mole ratio is going to be from your balanced equation, these numbers in front. Okay, so we can go straight from moles of one substance to moles of another because they're connected by this mole ratio. So I'm going to go ahead and put moles of the new substance on top, which happens to be water, and that is H2O. So it is very important that you are putting a number, a unit, and a compound in every box, okay? Because you're changing substances now, all right? So the only time you are changing substances is when you're using the mole ratio. And the mole ratio will be moles over moles, and it'll be a different compound, okay? Now, the first time you have moles on the bottom, I want you to circle it, okay? Now, that sounds really dumb, But the reason why I want you to circle it is because that's going to tell your brain that that is the mole ratio, and that is when you are changing compounds. Okay, so the first time you have moles on bottom, that is when you're also going to have moles on top, and you're going to switch compounds. Okay, so I want you to circle it every time moles is on bottom the first time. Okay, so inside of the circle, the rules are going to be kind of different. Okay, previously, outside of the circle, which we never used before, previously the number that always went with mole was a 1. Okay, you think back to the little map, it's 1 mole and 1 mole. But when we're using the mole ratio inside of the circle, that's when I'm going to look at the numbers here in front. Okay, so the number in front of O2 is a 1 in the equation, and the number in front of H2O is a 4. That is our mole ratio. This is 2 to 2 to 4 to 1. That is a ratio, okay? But the ones that we're concerned with are the ones that we wrote down. Inside the circle is when I'm going to use this number here in front, okay? So we're still going to cross things out like we did before, okay? The only thing that cancels this time is moles of O2 because moles of H2O is different. They do not match exactly. Again, we're asking for moles of water, and that's exactly what my top box is in. I'm going to solve this the same way I have in the past. Multiply the top and divide the bottom. Okay, so we're going to do 15.0 times 4, and then divided by 1. Okay, times 4 divided by 1. That's all they typed in. All right, so I got 60. Okay, so I have a problem with that number. First of all, it doesn't have a unit. And second, it needs to be sig figs. So how many significant figures are in this given here, this first box? That's 3. That trailing 0 counts with a decimal. So I need 3 in my answer, so I'm going to add a 0.0 to make it have 3. So 60.0 moles of H2O. That is my answer. Notice it has a number, a unit, and a compound. A number, a unit, a compound. A number, a unit, a compound. The only time you will switch compounds is inside of this circle, the mole ratio. Okay, let's try another one. Same equation. How many moles of nitrogen gas are produced if we started with 6.1 moles of ammonium nitrate? Okay, so our given is 6.1 moles. Now, I need a formula. So if we look at all of these things I have up here, does N2 sound like it would be ammonium nitrate? Probably not. That sounds a little too complicated. What about H2O? Is that ammonium nitrate? No, that's water. And then O2, of course, is oxygen. So the only thing that's left is this crazy, weird-looking thing. So that's what we're going to write in that box. Okay? So 6.1 moles and then ammonium nitrate. We're never going to put anything in this box. So if you want to draw an X, that's fine. All right, so right now I have moles of NH4NO3, and I'm looking for moles of nitrogen gas. So that's going to be our N2. So we're starting with moles of this, and I'm asking about moles of this. That is a different substance, which means I'm going to have to use that mole ratio. So let's look here. I'm starting with 1 mole. I'm starting with moles of, not just one. I'm starting with moles of ammonium nitrate, which is our substance A, and I'm trying to get 2 moles of substance B, which is nitrogen gas. So I can do that in one step again, using the mole ratio. Okay, so I'm going to go directly from moles to moles. So right now I have moles of NH4NO3 on top. So moles of NH4NO3 is going to go on the bottom, so we can cancel it in a minute. And then I can go directly from moles to moles. The first time I have moles on bottom, we're going to circle it. That is our mole ratio. That's when I can change compounds. Okay, moles of, and then my new thing is asking nitrogen gas. Well, that's our N2. So I'm going to write N2. All right, so inside of this circle, mole is not always a 1. It's the numbers in front of the balanced reaction. So NH4NO3, the number in front of it is a 2. And the number in front of N2 is a 2. Okay, so whatever number's in front is going to go inside the circle with your mole ratio. All right, so let's talk about things that cancel. Moles of NH4NO3 cancel because they match and they're on top of each other. That leaves me with moles of N2, and I'm asking how many moles of nitrogen gas. Okay, so we're going to solve the same way we have in the past. Multiply the top and divide the bottom. Okay, so we're going to do 6.1 times 2 divided by 2. So we multiply the top and we divide the bottom. Okay, and then you get, switch pens back. All right, you get the exact same number because basically the 2's kind of cancel each other out. So 6.1 is the same number of sig figs that we started with in the given. And then my unit that didn't cancel is moles of N2. So that would be my answer for that, okay? So let me show you how to do it when you have more than that. So you have more examples on your sheet, okay? New equation, balanced equation we're gonna use. This one says, how many moles of zinc are required to produce 20.1 grams of zinc chloride? So you're gonna have to pay attention to what we're given and what we're asking for. So I'm gonna go ahead and start with this. 20.1 grams of zinc chloride. So let's look at our symbols here. We have Zn, well that's just zinc. We have HCl, that doesn't have zinc in it, so that can't be zinc chloride. We have ZnCl2, that's probably zinc chloride, and then we just have H2. So that's gonna be the formula that I'm looking at. So ZnCl2. Draw my line. Nothing goes in this box. Same as before. Okay, so looking back at your little map, this time we're starting with grams and we're trying to go to moles of zinc. So that is a different substance, okay? We're starting with zinc chloride, grams of zinc chloride, and we're trying to go to moles of zinc, okay? So we have grams of substance A, and we're trying to get to moles of a new thing. So grams of A to moles of B is where we're trying to go, here to here. So can I do that in one step? Is there a line connecting those? No. So that means I'm gonna have to go from grams of A to moles of A, then use my mole ratio to get to moles of B, okay? So I'm gonna have an additional step in there. Grams of A to moles of A, then to moles of B, okay? So I'm gonna be referencing that again. All right, so right now we have grams of ZnCl2. In order to cancel it, we have to have grams of ZnCl2 on the bottom. And then we just said from grams of substance A, we have to go to moles of substance A. We can't really go anywhere else to leave that box. So we're gonna go to moles of ZnCl2. Okay, so cancel-wise, our grams of ZnCl2 and grams of ZnCl2 are gonna cancel in just a minute, okay? Right now, on top, I have moles of ZnCl2, so I need it to cancel. So I'm gonna have moles of ZnCl2 on the bottom. Oh look, this is the first time I have moles on the bottom. That means it's my mole ratio and I'm gonna circle it, okay? Notice I didn't circle this one. This is not moles on the bottom, okay? It's the first time you have moles on the bottom. That is your mole ratio, and that is when you're gonna also have moles on top and your new substance. So the new substance is zinc. So the symbol for zinc is just Zn. Okay? So this is the whole reason behind the circle. Let me show you this, okay? The whole reason behind the circle is so that you kind of separate when you use the mole ratio and when you don't, okay? So outside of the circle, the old rules apply, all right? Outside of the circle, mole is still gonna get a 1, okay? Outside of the circle, mole gets a 1. Just like on our little map, inside of that is a 1, that's gonna be the same. Mole ratio is when it will be different. Okay, so inside of the circle, that's when I'm gonna look for the numbers in front of the balanced equation. So I have Zn has a 1 in front, and ZnCl2 has a 1 in front. Now, it's not always gonna be 1. Remember in the previous examples we just did, sometimes they were a 4, sometimes they were a 2. It just depends on what was in front of those numbers in that balanced reaction. Okay, so the only thing now I'm missing is my grams. And where do I find grams? I'm gonna find that from the periodic table. So we're gonna do molar mass. told you guys that wasn't going away. So how many zincs are in this formula? 1. And how many Cls? 2. So let's look up their masses. Zinc's mass is 65.38. And chlorine's mass is 35.453. Okay, so we're going to go ahead and multiply those and add them. So 1 times 65.38 plus 2 times 35.453. So 136.286 grams per mole. Now, not my answer. That number is going to go in the box with the G. Okay, so now we can talk about things that cancel. So we have grams of ZnCl2 are on top and bottom, and they match. And then I have moles of ZnCl2 are on top and bottom, and they match. I'm ending with moles of Zn. Notice there is a number, a unit, and a compound in every box. Okay, a number, a unit, and a compound in every box. So, and the only time we switch compounds is inside of that circle, inside of that mole ratio. The first time you have moles on the bottom. Okay, moles has to be on the bottom for it to be the mole ratio and in the circle. Okay, so you're going to solve this the same way. You're going to multiply the top and divide the bottom every time there's a number on the bottom. So let's do that together. So 20.1 times 1 times 1 divided by 136.286 divided by 1. Okay, so we get this really big long number. Now, we need to round it to sig figs. The given has 1, 2, 3 sig figs in it. So we're going to round this to 0.147. The 4 makes the 7 stay. And then my unit is moles of Zn. Okay? So you must get used to writing that compound. The reason why I made you do it last unit is for this. So it wasn't like brand new and weird. Okay? Some of y'all got kind of lazy, so you need to make sure you're using it every time. All right, last example. How many moles of hydrogen gas, so that's going to be our H2, are produced if 38.3 grams of hydrochloric acid, remember all acids start with H, are used? So 38.3 grams of HCl. That's our beginning. All right, nothing goes in this box. This is going to be very similar to the previous example. So we're starting with grams of substance A, which happens to be HCl. We're going to go to moles of substance A because I'm asking ultimately for moles of hydrogen, which is a new substance. So I'm going from grams of A to moles of A, then to mole ratio to get to moles of B. Okay, so same exact kind of setup. Grams of A to moles of A, then to moles of B using the mole ratio. All right, so if this is grams of HCl on top, on bottom, we have to have grams of HCl, because in a minute we're going to cancel. Then we just said on our little map, we're going to go from grams of A, or HCl, to moles of HCl. And we're not done, because we're trying to get to moles of hydrogen. This is not just hydrogen. So we're going to have to go one more time. All right, so we have moles of HCl on top. We need it to cancel, so I'm going to put moles of HCl on the bottom. And that immediately tells me that that is my mole ratio. The first time I have moles on bottom is my mole ratio. Okay, and that's when I'm going to go moles to moles and change my compound. So instead of HCl, I'm going to write hydrogen, and hydrogen in this equation is H2. Okay? So outside of the circle, outside of that mole ratio circle, mole still gets a 1. Okay? Outside of that circle, mole is still a 1. Inside of the circle, I'm going to look for the numbers in front for the balanced equation. So in front of H2 is a 1, and in front of HCl is a 2. So remember, inside the circle, that's when I can change those numbers up. Okay? And then grams is going to come from the periodic table. So we're going to need to do molar mass. So we need HCl. There's one H in this formula and one Cl. So H's mass is 1.008. Cl's mass is 35.453. Okay, so we're going to multiply and add those together. 1 times 1.008 plus 1 times 35.453. So 36.461. All right, so that number goes in the box with the G, with the grams. All right, so let's talk about what cancels. Grams of HCl on top, grams of HCl on bottom. Moles of HCl on top, moles of HCl on the bottom. So I'm going to be left with moles of H2. I'm asking for moles of hydrogen gas. That is H2. All right, to solve, you're going to multiply the top, divide the bottoms. Okay, so let's do that part. 38.3 times 1 divided by 36.461 divided by 2. All right, so again, another number less than 1. So we're going to round to sig figs again. This beginning box here has 3. So this is going to be 0.525. The 2 here makes the 5 stay the same. And the unit is moles H2. Okay? So your actual assignment, okay, your actual assignment is listed where it says assignment. So you have 3 on the front, where it's just one step, moles to moles. And then you have 3 on the back, where it's just like this exact same setup, with obviously a different formula and all that. Okay? And we're going to learn more of this tomorrow. Make sure you're keeping track of this, okay? This is super, super important. We're going to keep adding steps to it as we go along.